So now we're continuing with chapter 18, which is talking about the interrupt interface to the processor. So again, for us, we're using the same architecture as the Pico Blaze. The behavior is the same. Some of the differences you need to keep in mind as you read the literature is that our memory space is 4K 16-bit instructions as opposed to 1K 18-bit instructions. In the implementation of the Pico Blaze, they were able to then use instruction 3FF or location 3FF as the vector to the interrupt service routine. For us, when we do a jump to a particular address, we need 2 words to implement that because our instruction set is only 16 bits wide. So what that means is our vector address is FFE. If in your implementation of the Trammell processor you ever want to reduce the size of the memory, you just need to go back into the Verilog and change the vector FFE and then also in your code. But the important thing is that it's not FFF because we need 2 words in order to house the jump instruction. This diagram shows what happens when an interrupt occurs. So the 1 is saying we're executing the add instruction. The interrupt happens. Okay, 0 was we enabled the interrupts. 1, we executing the add, interrupt occurs. So the machine will complete the execution of this instruction. It'll then jump to FFE, which will have the jump to the ISR instruction, which then sends us to the routine that we should have written in our code to perform whatever functionality we want to perform in the interrupt service routine. At the end of the interrupt service routine, we execute the return from interrupt instruction, enabling, in this case, our mnemonics a little different, but it's the same function. We return, and that will then take us back to the instruction that would have been executed had we not been interrupted. So all of this flow shouldn't be that confusing. It's fairly straightforward. What's the takeaway? The takeaway is we need to put our interrupt vector at location FFE. And in our code, we write the interrupt service routine, the last instruction of which must be a return from interrupt. You can return from interrupt with interrupts enabled or disabled. But this is the basic structure we have to implement in our code in order for the machine to function properly. This is just showing you the timing of what's happening. Ours looks the same. What may be a little different is the number of clocks per instruction in my machine may not mimic his exactly, but the basic flow is the same. The interrupt ACK will look the same. So what we've done in our current project is that the interrupt is set when the button is pushed. When the processor responds with an interrupt acknowledge, it knocks down the interrupt. This is basically our implementation. We're using an SR flop. He calls it SC. In either case, it's a synchronous implementation. The interrupt request comes in, the interrupt gets set to the processor. Once the interrupt is serviced by the processor, he then generates the interrupt acknowledge, which will clear the interrupt. What he's showing you now is that if you choose to do so, you could have multiple interrupt sources, in which case Since we only have one interrupt coming into the processor, we'll always go to the same interrupt service routine. For you then to distinguish between who was the source of the interrupt, you would then need to add to the read path to the processor the registers that are being set when the interrupt requests occur. Then the processor can decide, okay, I want to service 0, I want to service 1, whatever his prioritization scheme may be. In that case as well, it's not an interrupt acknowledge that's used to clear it, but there has to be direct code to allow the processor to clear the interrupt source of the interrupts that he is servicing. So now he's just walking you through how it is. You set it up. We do the same address, FFE, jump, interrupt service routine. Then we have a label, interrupt service routine that has our code, the end of which is our return from interrupt, either with interrupts enabled or disabled. Now he's giving you an example for you to walk through much more detail. Talk a little bit about the interfacing to the processor, which we've discussed in the diagrams up above. And that's it on the interrupt service routines. It's really fairly straightforward. Where it becomes interesting is if you want to elaborate and increase the number of possible interrupt sources that your processor is responding to, then you have to develop an external IP from this processor that would serve as your interrupt controller. If you recall, in the ARM world, they have what they call the vectored interrupt controller. They have a very sophisticated interrupt controller in the later generation products, all of which are providing the exact same functionality. They allow external events to get the attention of the processor and have the processor service that interrupt source. Okay, so that's it for that chapter.